So we have a date written on our notes. We're all comfortable with that, right? Okay, so today is September the 1st. That's excellent. So, September Fool's Day, absolutely. Okay? We're gonna start talking today about transformations. And we're going to talk about them today, and we're going to talk about them Tuesday. So 2 days in a row we're going to talk about the same thing. That must mean it's really hard. No, it does not. It means it's very important. And not only going to talk about it now and Tuesday, we're also going to talk about it like 8 other times this year, this school year. Because every time we get to a new parent function, we're going to talk about transformations again. Okay, so hopefully by the 7th time you'll have it down. I'm just teasing about that. Hopefully by like the 2nd time you have it down. Okay, but so in previous years people have said, "Oh, we've already done this." So you're complaining that you're about to get 100 on the homework? Is that what I understand? Okay, no, we're not going to do that, right? Okay, you're just going to take your homeworks and your hundreds on your homeworks, and you're going to like it. Okay, all right. So first things first. Let's look. You're going to learn very quickly that I am a visual learner, okay? I've got all these markers right here to use in your notes today. If you like to use markers to help differentiate things, that's perfect. Use them. If you would like to use different colors to differentiate and don't have them, I have some right up here on this table. Just come and borrow some. Just please return them. Don't steal pencils. That's dumb. Okay? I mean, don't steal cars either. That's dumb also. Just don't steal. No stealing. Okay?
Unless you're stealing it back.
No stealing. Okay? So let's start out and let's talk about this. Oh, pencil. Please tell me what parent function that is.
That's a root.
Close.
Square root.
It's a square root function, okay? That's a square root function, and what is its equation? Yeah, the square root of x, right? Okay? Now, as we start this discussion, I'm going to be using some words that I know you're familiar with, okay? It may take you an example or two to understand how I'm using them and why I'm using them the way that I am. So if you don't understand on the very first example, at least give me to the second example before you start asking exactly what I mean. Is that fair? Okay. So here's the parent function. Okay? If I write y equals the square root of x plus 2, I want you to notice that the 2 is on the outside of this function. Do you have a general idea of what I mean by outside of the function? Okay? If it was inside of the function, where would it be? It would be under it, right? Under the radical, right? It's outside of the function. When things are being added or subtracted on the outside of the function, let me change what I just said. When things are happening on the outside of the function, that causes a vertical change of some sort. Vertical. Okay? So this is going to be a vertical change. Okay, so the first thing I want to make sure you understand is this is how you spell vertical. It's not V-E-R-T-I-C-L-E. It's not, I promise. Okay, so let's make sure we can all spell vertical correctly. But then we have to decide what kind of a vertical change. Okay, vertical change, if something's being added or subtracted onto the parent function, that is going to cause a vertical shift. Now, I need to be very, very clear with you, and I need you to completely understand this part. This F is so important. If you leave it out, it's a different word. And you laugh as if someone has never turned in their test for getting their F. Yes, they have. Yes, they have. Okay? So, let's remember our F's. Thank you. Let's remember our F's when we are writing this word. Everybody okay with that?
Yeah.
Okay. It's a vertical shift. Well, can we use a little bit of logic here? If it's a vertical shift, it's either going to go up or down.
Down.
This says plus 2. So does it make sense that it would go up 2? Yeah, we're just using logic right now, right? So, like, what part of this function moves up 2? Like, specifically, yeah, we want to start there, but how many of these values of the function move up 2? All of them, right? Now, this is the easiest one to take care of because it has a specific spot, right? It's at the origin. So if I move this thing up 2, it's pretty clear where the rest of it also goes. But notice this point moved up 2, this point moved up 2, this point moved up 2, and so on. Does that make sense? Good. You okay so far? All right, what about this? What if it said y equals the square root of x minus 3? Where is the minus 3? Inside or outside?
Outside.
If it's outside, what kind of shift is it? It's a vertical, change. It is a vertical change. And since it's being added or subtracted, it is a shift. S-H-I-F-T. And since it's minus 3, it's down 3. Again, this point is the easiest to see because it has a definite spot. So if I move it down 3, I know that's where I start. Now, how do I know that it doesn't go like this? Like, whoosh. If I cover up this minus 3, is this changing shape from the parent? No, it's exactly the same as the parent, right? Only thing that happens is all of the points are moving up 3. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay? Is everybody clear on that? So are we okay on vertical shifts? Okay, let's go to another example then. Can you tell me what parent function that is?
Absolute value.
Absolute value, and what is its equation?
It's the line and the line.
Yeah, it looks like an X that's in jail. That's what I was told the other day. The X is in jail. My concern was that person had too much experience with jail. So, what about if the equation said this? Is that 2 inside or outside of the function?
Inside.
That's inside. Can you tell the difference between inside and outside now?
Yeah.
Does that make a little bit more sense? Okay, so this is inside of the function. It's still something that's being added or subtracted, so it's still going to be a shift. But what direction do you think this might go?
Sideways, horizontal.
So horizontal, right? H-O-R-I-Z-O-N-T-A-L. Horizontal. So it's a horizontal shift, we decided already. But here's the thing about horizontal. Horizontal is weird. It's going to be opposite of what we think. So if it says plus 2, which direction is it going to go? Left 2. It's not going to go in the positive direction. It's going to move in the negative direction. Horizontal shift, left 2. So again, this absolute value parent function has a nice, easy place to move, right? It's called a vertex. So I could move the vertex left 2. Now I could move every point left 2 because that's what's happening. But again, is it changing shape?
No.
No, because if I blocked out this, that's exactly the parent function, right? So it's going to be the same shape as this function was before. That's a weird looking arrow. I'm sorry. Any questions about that? Then please tell me about this one.
The right one.
Horizontal shift right 3. 1, 2, 3. Any questions so far? Guys, is something allowed to have a horizontal shift and a vertical shift? What?
Yeah.
Yeah, right? There can be a number inside and outside, can't there? Which one comes first?
The one that
It doesn't matter. Shifts, it doesn't matter.
Same place.
Okay? Yeah. So like if I had a horizontal shift right 3 and then up 2, I would end up right here. But if I went up 2 and then right 3, I would still end up right there, wouldn't I? Okay? Now, typically when I do examples for you or when I show you how to do some problems, I'm going to go left to right. Okay? So let's talk about this real fast. If it said y equals absolute value of x plus 2 minus 4. Whoa, there we go, minus 4. What's going to happen here? What's this going to cause it to do? This is going to be a horizontal shift left 2 and a vertical shift down 4. Does that make sense? What if it was this? I'm going to throw you a trick question. What kind of parent function is this? That's a quadratic, isn't it? A parabola? What kind of shift is it going to have compared to its parent?
it's going to go
Yeah, left 2 and down 4. What about if it was this? What kind of parent function is this? Exponential, because the variable's in the exponent. Where would it go? Left 2, down 4. What does this 2 do? No, that just gives it an original shape, right? That just tells you here's the base and there's the power, so it is an exponential function. The 2 is just giving it its original shape. That's like the parent. Okay? So do you see how learning like these rules in general will help you with every single function that we do? You okay with that? Okay? Let's go on to the next one then. Let's go and do an exponential one. Whoops. Arrow. Now, on any of the other ones, did I start making these lines to tell you about spaces at the very beginning with the parent? Then why did I do it here? Does every parent exponential function go through the point 0, 1? If I put in a 0 right here, what's 2 to the 0 power? 1. What's 10 to the 0 power? 1. What's 36 to the 0 power? What's 1/5 to the 0 power? Are you getting the idea? Does every parent function go through the point 0, 1? Yeah, so I specifically marked that point because exponential is just kind of like foofy. It just kind of zoom like that. This one has a specific starting point. This one has a specific starting point. Well, guys, now this one has a point that we can focus on when we move. Does that make sense? Okay. So let's start with this. Y equals -2 to the x power. Is that negative on the inside or the outside? It's on the outside, right? Where would it be if it was on the inside?
by the x.
That would be up in the exponent, right? So it's on the outside. So is it causing a vertical change or a horizontal change? It's causing a vertical change. Now, is it being added or subtracted like either one of these? No, it's definitely not a shift. It's a multiplier that's out front, but more specifically, it is a negative. Okay? Here's what happens when you have a negative. Can you tell me?
It says the opposite. Or the numerical.
So mirror, right? It mirrors it, but what kind of math word can we use for that?
What?
Yep.
Reflection.
Very good. Can you be specific for me about what it reflected over?
The y-axis.
Close. Yeah, x-axis.
Y-axis. What is it?
I don't know why you said that. It's okay.
I know what I was thinking. I just
Okay.
didn't say it.
Didn't we say, though, that it would be a vertical change because it was outside? Is this a vertical change?
Yeah.
Up and down? It sure is, isn't it? Okay. So we talked about this a little bit a second ago. What do you think it's going to look like if it's this? Is that inside or outside? It's inside. So it's a negative, so it's still going to cause a reflection.
But it's going to be.
It's going to be a horizontal change this way. Yeah, absolutely. Reflection over the y-axis. So if I reflect this over the y-axis, instead of going all the way that way, it's going to go all the way this way. And it's going to go like that. That's not too bad, is it? You okay with that so far? Okay. For today, I'm going to show you one more. And then you'll have the rest of the period to work on your homework. So tell me what parent function this is.
It's a parabola.
It is a quadratic that makes a parabola, so its equation is x squared. Where is it? It's on the outside, so it's going to cause a vertical change. Is it being added or subtracted?
No, it's being multiplied.
So it's not a shift. Because it's a 2, and we'll get here in a second, so just trust me for now. Because it's a 2, it is called a vertical stretch. So if I'm stretching something vertically, it's like I put my finger right here on the vertex and kind of take the shape and go and stretch it up that way so that it looks like this. Does that make sense? Now, to some people, including myself, it looks like we did this. Right? Doesn't it look like that? The only way you can tell the difference, whether it's a vertical stretch or a horizontal compression, is by looking at the equation. Where is this tube? It's on the outside. If it's on the outside, it is a vertical change. And you know I took a point and just kind of stretched it vertically. Or just like that way. Okay? Doesn't change where it starts because there's no shift here. But I stretched it vertically that way. That's how I know it's a vertical stretch and not a horizontal compression. Okay? So it's a vertical stretch by a factor of what? 2. This 2? This 2. Okay, what does this 2 do? Look at the parent. What does this 2 do? It gave it its original shape. It told you it was a parabola to start with. It doesn't do anything as far as a change to the parent, because that's what the parent is. Okay? So here, what's the other thing that we could have besides a stretch? Compression, right? So if we have y equals something x squared, what's going to make it a compression? Negative, we already talked about. Negative is a reflection. Tell me what you know about this number 2. It is being multiplied, but specifically about the number, it is a number that is greater than 1. Okay? It's a number greater than 1. That's what causes a vertical stretch. So what do you think is going to cause a vertical compression?
It'd be less.
It would be less than 1, but greater than 0, right? So give me a number that would be less than 1 and greater than 0.
16.
Okay, how about 1/2? That was a lot of good answers, by the way, for the record. A lot of good answers, okay? So this would be a vertical compression. By a factor of what? 1/2. That means I'm going to take the parent, not the blue one, but the gray one. I'm going to take the parent and squash it down half as high as it was before. So it's going to look like this. Does that make sense? Good. Now, is there such thing as a horizontal stretch and compression? Yes, we're not talking about it today. Okay, that's for a later day. So these are the notes that you're going to need to be able to have in order to do your homework tonight. I did an example on the other page. Let me do an example real quick on this page. You mean to make it a hard one or an easy one? Hard, because if you can do the hard ones, you can do all the rest of them, right? Y equals negative 1/3 x minus 4 to the 3rd power plus 10. That's about as hard as I can make it right now. So start here. What does that negative cause? Reflection over the x-axis, right? Then we get to the 1/3. That's outside. Is it greater than 1 or is it between 0 and 1? So it is a vertical compression. By a factor of 1/3. You okay so far? So we took care of the negative. Now we took care of the 1/3. What's next? The minus 4. Is that minus 4 inside or outside of the function? Inside. So if it's inside, it causes a horizontal shift. Good. Horizontal shift. Remember, horizontal ones are weird. So it's a horizontal shift. Good. Right 4. So I took care of that. What does this 3 do? Oh, good. It makes a shape, so I don't even mess with it, do I? And then I have plus 10, which is outside. So it is a vertical shift up 10. Done. You just did the hardest one. All the rest of them in your homework are easier than that. Any questions?